All right, so we're going to go ahead and get started, you guys. The very first lesson of this packet is an introduction to inverse functions. So this unit is going to cover all about inverse functions. And in this particular lesson, we will be looking at how to evaluate inverse functions through multiple representations. All right, so for your first activity of the day, you're going to have a warm-up. Now, I'm going to go ahead and help you guys get started on this warm-up. So I'll do the setup, and then I'll have you guys take care of that with your group. Now, in this warm-up, we have the following three functions. We have f of x, g of x, and h of x. And the first thing I would like for you guys to do is I would like for you guys to write the following words on top of the statement f of g of 4. You're going to write the words function, composition, just how I have it up here, okay? Once again, you're going to write function, composition right on top of the statement f of g of 4. Now, the reason why I'm having you guys write that down is because that is the name of this term, or whenever you solve for a function inside of another function. All right, that's known as function composition. Now, a lot of the work that we do with inverse functions is going to require us to rely on the use of function composition to go ahead and do that. So, this is something we learned in Unit 1, but maybe you don't remember. So let me go ahead and remind you how to do it. Suppose we want to solve for f of g of 4. You're gonna work your way from the inside out. You're gonna start by finding what g of 4 is equal to. That's gonna require you to plug in 4 into the function g. Whatever you get, you're gonna plug in to function f. Okay, so that output will become the input for the next function. So for your first activity, for your first participation activity, you and your group are going to work together on problems A through D. Okay, you are not going to work on problem E until after the timer has run out. Okay, so at this time, with your team, go ahead and work on problems A, B, C, and D. You may begin. I will be asking for some of you guys to help me out here. Hold on. I'll give you guys some time to think about problem E, and then you get a chance to answer problem E after we have completely answered A through D. So let's begin by looking at problem A. What is the value of f of g of 4? We need to begin by evaluating what g of 4 is equal to. So raising your hand, what is g of 4 equal to? Okay, Jim. So g of 4 is equal to 3. We take that 3, plug it into f. So what do we get when we plug 3 into f? What's the next solution? Luke? We get 11. You're good. You're good. No, you're good. Yeah, that's good. F of 3 is 11. Okay. So then we can go ahead and jump to the next one. We already know that f of 3 is 11 from what we just did. We're going to take this 11 and plug it into g. What is g of 11? What is g of 11? 17. G of 11 is 17. Okay. All right. Now, we are going to look at the following two functions, h and f. So we begin by evaluating f of 4. That means you're plugging in 4 into function f. What do we get when we plug in 4 into f? Me from Anthony Moreno. 13. When we evaluate h of 13, then what do we get? Story, what do we get? We get 4. Okay. All right. Let's jump to the next one. F of h of 11. We begin by evaluating h of 11. What is h of 11? Joel, what is h of 11? 3. We take the 3, we plug it into f, and f of 3 is equal to 11. Now, we can go ahead and look at the next question. What happened when you used f and h together, what is special about this pairing of functions? What I'm going to have you guys do right now is, first, I want you to think about the inputs and the outputs for these two functions. What did you notice about these functions? All right, I'm going to give you guys some time to think. So let me give you 30 seconds to try to find a connection between the inputs and outputs, and you're going to write a sentence down. This is individually. All right. Then I'll give you guys a minute to pair up with someone at your table and share your thinking. Then I'm going to call on someone randomly, and you're going to tell me your partner's thinking. The initial input is the same as the final output. Okay. Once again, if you don't have anything similar to this, you need to write this down and include it in there. And if you do, that's good. This is actually the whole premise of inverse functions, is this idea that the inverse function, the inverse function has an initial input the same as the final output. All right. Who's next? Okay. So we're going to go ahead and move on to some notes now. Like I said, there's a special name for pairs of functions that behave in this manner. They are called inverse functions. So go ahead and fill in this blank with the word inverse. And then functions, inverse functions. Okay. And I'm going to give you guys some examples of inverse functions that are very basic. For example, the inverse or the opposite of adding is what? Subtracting. What about the inverse or the opposite of multiplying? Dividing. So these are inverse functions, right? Now think about what's going on as one inverse affects the other, right? So if I add 3, but I do the inverse, which is to subtract 3, then what just happened there? Once again, I started with a 3, like I added a 3, but then I subtracted a 3. So what actually happened? Nothing happened, right? Like one thing canceled the other thing out, right? One function undid what the other function did. So that is what we're going to write in the second blank. These functions undo each other. Okay? So here are the blanks. The first blank, inverse function. Second blank, undo. Now, I am going to fill in the following using problems C and D as an example. And this is kind of like a flow chart here. So in the problem C, we start with an input of what? What is the initial input? The 4. We start with the 4. So 4 is going into the first function, which is function f. And f of 4 gives us 13, right? This is what we got in part C. F of 4 is equal to 13. We then took 13 and we plugged it into which function? What's the second function? H. So we then evaluated h of 13, and that gave us an output of 4. As you can clearly see, the initial input and the final output are the same. We start with the 4, we end with the 4. Okay? Let's go ahead and look at the next example. In part D of the warm-up, we started with an 11, and it got plugged into function h. So we did h of 11. H of 11 gave us 3, which we then plugged into f. And what was the resulting answer? It gave us back 11, which is what we started with. So 11 spits out 11. Okay? This goes back to that idea of the initial input, your first input, being the same as your very last output. All right, when those things happen, that's a case of inverse functions. Now, we're going to explore the notation for inverse functions. In examples C and D, we talked about the fact that f and h, these two functions are inverses. So f of x can be written as its inverse function, which is h. The way you write inverse is with a -1 that looks like an exponent, but do not get confused. It is not an exponent. It's just notation. So that's how we would write it. f of x can be written as h inverse of x. Verbally, we would say this is h inverse of x. The little negative 1 means inverse. H inverse of x. Okay? So f can be written as h inverse of x, which means h of x can be written as f inverse of x. And we would say f inverse of x. Okay? So starting next class, you're going to see it in this notation. Anytime you see a little negative 1, that means inverse, all right? We're going to do more exploration on that next class. Because we actually won't finish the entire lesson today. All right? So remember that the goal is to show you guys how to evaluate inverse functions 3 different ways. In the next page, we're going to look at those 3 different ways. The first way is with functions, the second way with tables, and the last way with graphs. So let's go ahead and jump into that together, all right? Scroll down to the next part or flip your page. And I'm going to show you guys how to figure out which function is the inverse of another function when given an equation, when given a function. Now, the starting function is the function f of x. So what I'm going to begin by doing is I'm going to pick a number. Actually, I'll have you guys pick a number. I want you guys to pick any number that can be divided by 2. 8. Let's go with 8. All right. Now, actually, before we move on, I want you to write the following on top. I want you to write the goal so we don't forget what the goal is. The goal is for the initial input to be equal to the final output. That is the goal. When this happens, we have a case of inverse functions. So that's what we're trying to figure out, is which of the functions is inverse, well, which of the functions gives you the initial input. All right. So we said we're going to figure out what f of 8 is equal to. So f of 8 would be 8 over 2 plus 3. 8 over 2 plus 3, right? So 8 divided by 2 is 4. 4 plus 3 is 7. So f of 8 is 7. Now in this example, 8 is the initial input. What I'm going to have you guys do in the next few minutes is this output of 7, you're going to plug into g. So you're going to evaluate what g of 7 is equal to. And then you're going to evaluate what h of 7 is equal to. And whichever of these 2 functions gives you back your initial input, that function is the inverse. Make sense? All right. With your group, you have the next 3 minutes to solve for g of 7 and h of 7. Go. Okay, let's see what you guys came up with. So, first, we take 7 and we plug it into g. What do we get? G of 7 is equal to what? Raising your hand. What is g of 7 equal to? Lorenzo? 11. Is that the answer that we're looking for? No. What are we looking for, Joel? 8. So, g is not the inverse. We can cross that out. Okay, so we take 7 and we plug it into h. And when we take 7 and plug it into h, what do we get? We get 8. Let's double check. 2 times 7 minus 3. That's 2 times 4, which is 8. Yes, that checks out. So h of 7 is equal to 8. That means that h is the inverse, right? So once again, we want to get to that part where we're showing that the final output is the same as the initial input. In this case, 8 equals 8, right? We can see those 2 numbers that are being highlighted. All right. Now, I'm going to show you guys how to write these as statements, as function composition statements. So pay attention here. So what was the first thing that we did? We took 8 and we plugged it into which function? Based on the problem we just did, 8 was plugged into which function? F. So we did f of 8, right? That's the first thing we did. When we solved that, we plugged it into which function afterwards? Think about what we did. We took 8, we plugged it into f and got 7. The 7 got plugged into which function? Which one was the inverse? Not g. G is not the inverse. Which one's the inverse? H. So we took f of 8 and we plugged it into h. And what was the final answer? Look at this final answer here. What was the final answer? 8. Okay. So h of f of 8 is equal to 8. Right? We are showing here that the initial input is equal to the final output. That is what you want to show in order to consider something an inverse function. H of f of 8 is equal to 8, where the initial input is equal to the final output. So those two numbers in this statement need to be the same. Okay? Now, I'm going to have you guys help me out with the second statement. Instead of writing this as h of f of 8, I'm going to flip the order of the functions, and I'm going to start with h. Now, I want you guys to give me a number, any number. 4. H of 4, let's say we were to plug that into f, so that we would have the following statement. F of h of 4. What is the output supposed to be? The output, so that this is considered an inverse function, is supposed to be the same, which means that it has to equal a 4. Okay? So we don't actually have to do any calculations for the second statement. You just want to write a statement where the initial input and the final output are the same. Okay? All right. So that is the first method with equations. Are there any questions before we move on to tables? All right, then let's jump to the next problem where I'm going to show you guys how to identify what the inverse of a table is. Now, I'm going to have you guys write the following. In case you forgot, but on a table, the left column represents the inputs, the right column represents the outputs. So here we have the left side, which would be the initial inputs, and the right side, which would be the initial outputs. Now, in this case, I labeled both of them initial because initial meaning my first function. All right, my first function is function j. Now, what is it that I'm trying to prove? For something to be considered an inverse, what am I trying to prove? Look back at that goal that you wrote at the top of the paper. What are we trying to prove here? Which ones? Look back at the goal you wrote on the top of the paper. What does it say? What does this goal say, you guys? The initial input needs to equal what? The final output. Now, in this table, I have initial input and initial output. What we're trying to do is figure out where do we see the initial input being the same as the final output. So I'm going to go ahead and label the other two tables. This one would be final input on the left side and final output on the right side. Repeat the same step for the next table. Final input on the left, final output on the right. Okay. I'm going to repeat that again. We want the initial input to be the same as the final output. So we want the numbers under the initial input column to match one of these two. So look at the numbers under initial input and figure out which of these two tables has those same numbers. It's all visual, right? So look at these numbers and match them with one of these two tables. They need to be exactly the same. Go ahead and do that now.
supposed to write something?
No. Right now you're not writing anything. You're just visualizing it. You're just trying to see it up there.
So we're just looking?
Yeah. So you're just comparing this column, and you want to match it to one of these two. Second one? Okay. All right. So let me get your attention up here. Once again, we are looking at this column, you guys, the column on the left, and we want to match it to either this one or this one. Now, look at these two final output columns. Which one is the same as the initial input? Is it the first table or the second table? It's the second table. And we can see that because we have -2, -1, 0, 3, and 5. And over here we have -2, -1, 0, 3, and 5. All right? So we can see that these two are the same. Because these two are the same, that means that function m is the inverse. Now, you want to go a step further and confirm that the other column is also the same. And we can see that it is. Here we have 10, 9, 5, 2, and -1. Here we have 10, 9, 5, 2, and -1. So with that in mind, we have shown that function m is the inverse of function j. All right? So we can cross this one out. This one is not the inverse. This one's the inverse. Okay. Let's go ahead and write our statements down. So we're going to start with the first function, which is j. Now, I want you guys to pick a number from the yellow column. Any number. 0. So let's say we wanted to evaluate j of 0. J of 0 would need to get plugged into m. And in order for these to be considered inverses, what must by final output be equal to? 0. Right? Where these two are the same. So that's your first statement. M of j of 0 is equal to 0. Okay? Let's go ahead and do our second statement now and switch the order of the functions. Let's start with m. Now, because we're doing m, then I need you guys to pick any number as long as it's from the pink table, from the pink column. Which number? 2? Okay, let's do m of 2. M of 2 would get plugged into function j. And for these two to be inverses, what must my output be equal to? 2. There you go. Okay. All right. Are there any questions so far? So I just showed you the second method. The second way is to show or to figure out which one's the inverse with a table. I'm now going to show you the third way, and then we'll take our break. Sound good? I'm going to show you the third way, which is with the graphs, and then we'll take the break. All right, let's move on then. So we want to figure out which of the following two graphs is the inverse of n of x. So this is how you do it. You make a table. Start by making a table for the following 3 points. X and n of x. The first point is -1 and -3. The second point is 0 and -1. The third point is 1 and 1. In the next few minutes, I'm going to have you guys come up with a table for each of these graphs. Okay? So I'm going to put the points, I'm going to write them down, and then I'm going to have you guys go ahead and come up with a table for it. So I'll go with this point, and this point. X and P of x. And then this point, and this point. All right. So I'll give you guys a few minutes to go ahead and fill out these two tables for x and P of x, and then x and R of x with those points that I put up there. All right, go ahead and take care of that right now, please. Okay. So hopefully you guys were able to do that. If not, I'm going to help you out now. What is the first point? Going from left to right. This point right here. What is the point there? Let me go ahead and okay, some of you guys help me out here. KJ, what is this point right here? -3, comma -1. Good. Next point. What is this point right here? Aiden, what is that point right there? Blue. The one I'm pointing the arrow at. -1 and 0. Okay. Last one. What is the value of that point right there? Let me hear from Jaden. She's not here today, right? Risa. 1 and 1. Thank you. Okay. Let's move on to the next one. What is the value of this point in red that I'm pointing at, Lorenzo? -1 and 3. The next one, Kayla. 0 and 1. And then the last point, Anthony Diaz. 1 and -1. Okay, so the goal is for the initial inputs to match the final outputs. So we want to figure out which of the other two tables has -1, 0, and 1. So look at these tables. Which of these tables has -1, 0, and 1 on the right side? Is it P of X or is it R of X? P of X. We can see -1, 0, and 1 in P of X. We do not see that on the right side for R of X. So that tells us right there that P of X is the inverse function. This is the inverse function. Let's go ahead and write our function composition statements. So if we begin with N, that means you pick any input that is in the yellow column. So pick any number from the yellow column. 1. N of 1 will get plugged into P, and since they are inverses, what will my output be equal to? If it's an inverse, it must be the same. So it spits out a 1. Let's flip the order of the functions. N of P of any number that is not in the yellow column. -3. So N of P of -3 must equal what? -3. Okay? And those are two example statements that support this choice. All right. We're going to go ahead and pause right here. When we come back, we will do the you try portion.